over here, I have a polygon. It has 1, 2, 3, 4, 5 sides. It is a pentagon. Now, looking at this diagram, is this a regular pentagon? Does it look regular? No. The sides appear to be of different lengths. If the sides are of different lengths, then the angles are also different. It's quite evident, it's quite obvious over here. So now this car is traveling to the right. Okay, I'll just play the animation for you and watch as it turns. Okay, as it turns, it makes an angle, right? So this blue angle, known as A, is the exterior angle of this part of the pentagon. So now it is traveling this way, it is turning again, and it makes an angle of B, that is the other exterior angle. So here for a pentagon, we expect 1, 2, 3, 4, 5 exterior angles. Does that make sense to you? Okay, now let's show the measurements. These are the values of A, B, C, D, and E. That's a question. What is A plus B plus C plus D plus E equal to? It is the sum of the exterior angles. What is this sum equal to? Would you like to use your calculator and find out? Just press the calculator real quick. 73.9, 80.2, 360.1. Okay, but is it very close to a certain number that you know? It's very close to 360, right? Okay. Let's ignore this 0.1 first, because of the way that this is designed. Because of the way this is designed, it is not very accurate. Okay, but what we are expecting to see is 360 degrees. There is some rounding off over here. That is why you didn't get 360 exactly. Okay, now I can change all these points over here, and you see that the angles change, right? As I move the points around, the angles actually change, and the values, the angles also change. But if we were to add everything up, what do you think it is going to give me? It's still going to give me 360. At this point, are you convinced that it is always 360? Are you convinced? You can be honest. Not convinced, right? Actually, if it is me, I'm also not convinced. Let me show you something else. What if I zoom out? What do you see happening? What do you see now? Angles at a point. It is angles at a point. So no matter how many sides there are, no matter whether it is regular or irregular polygon, if I were to zoom out, I will always get 360 degrees. Okay? Let us just verify that quickly with a triangle. For this triangle over here, okay, assuming this is a equilateral triangle. So we've got 120 degrees here, 120 degrees again, 120 degrees. How much does that give us altogether? 360. What if it is not an equilateral triangle? What if it is 20, maybe it's let's try 50 degrees over here, then 65 and 65. So this is an isosceles triangle. Okay, so here we get 130 degrees. This is 115. And over here, another 115. Let's add everything up. 115 times 2 plus 130. We get 360 again. Okay? Okay, right now we can confirm that whether it is 5-sided or 3-sided, we get 360 degrees. What about a square, a rectangle, trapezium, parallelogram? You should know that for interior angle 90, exterior must also be 90. Times 4, you get 360 again. Of all these shapes, if you were to zoom out for all of them, you will always see that it is 360 degrees. So even for the general case, n-sided polygon, also 360 degrees. Okay? Now, state the general formula. Is it really a formula? No, it's not really a formula. The sum of the exterior angles of an n-gun be 360 degrees. There's no formula. Okay, so next part, we're going to try some questions. Find the number of sides of a regular polygon if each exterior angle is 24 degrees. Okay, one of the angle is 24 degrees. This is regular. So all interior angles are equal, right? That is what we have learned so far. Now, if all the interior angles are equal, what can you tell me about the exterior angles? They must be the same. Logically, they must be the same. So here we have a new knowledge. Our new knowledge is that, hey, if it is a regular polygon, all exterior angles are equal. Alright, all exterior angles are equal. Now they are telling us that each exterior angle is 24 degrees. One of them is 24 degrees, and all of them are actually 24 degrees. So how many sides are there? How many exterior angles are there? (360) divided by 24, right? We can say, for very complete word, we say that let number of sides be n. So if there are n number of sides, then we have n number of exterior angles. Each exterior angle is 24. So total exterior angles must be n times 24 degrees. So total exterior angles is n times 24 degrees. And this must be equal to 360 degrees. We found that out earlier. So n, like Rian correctly pointed out, will simply be 360 divided by 24 degrees, which gives us 15. 15 sides. Okay, question 8 is your homework. It is the same question actually, just that the numbers are different. And here they give you interior angle. Okay, so take note, this is interior angle 120 degrees. Before we learned exterior angles, could you have done this question? You could. You would have done n minus 2 times 180 divided by n equals to 120 degrees, right? But now, what is the other method using exterior angles? Is it going to be easier? I think so. You can try yourself as a homework. Okay, so now let's move on to question 9. A polygon has m sides. Two of the exterior angles are 21 and 39. The remaining m minus 2, okay, they're very kind over here. They told you that there are remaining m minus 2. Earlier on, we had to do n minus 4 ourselves. So now they tell you that remaining m minus 2 are 15 degrees each. Find the value of n. Okay. Would you like to use interior angles or exterior angles to solve this? Both ways will work. One way is easier. Exterior angles is slightly easier. Okay? So we know that the sum is going to be 360. Let's write down total. Exterior angles must be 21 plus 39 plus m minus 2 times 15 degrees. Expand. 21, 39. 21 plus 39 minus 30. So we have 30 degrees plus 15 degrees m. Okay, so this is our total exterior angles, and we know that this has to be equal to 360 degrees. Therefore, so this arrow over here means therefore 15 degrees times m is equal to 330 degrees. M must therefore be equal to 330 divided by 15, and we get 22. Omera, is the pace okay? Anybody finds it too fast? Okay, then the next part, find the sum of the interior angles for the polygon. Sum of the interior angles. How do we find the sum? Use the formula that we have learned. Sum equals to total number of sides, which is 22, minus 2 times 180 degrees. So we get 3600 degrees. Okay, question 10 is your homework. Again on ratio, similar to your homework question yesterday. Please don't do it now, because I've got more questions over here to go through with you. Okay, question 11, I'm going to give you a hint. It is going to be a homework question also, so let's read this question. PQRSTU is a regular hexagon. If they tell you it is a regular hexagon, it means that we can calculate every single interior angle, which means I can calculate every single exterior angle. The sides ST and PU are produced to meet at V. So we extend this out to meet at V. Find the values of X, Y, and Z. X is not a problem, it's just the interior angle formula. Y over here, there are two ways to do it. First, you use 360 divided by, to find the exterior angle, 360 degrees divided by, how many sides? 6 sides. This is a 6-sided figure. 360 divided by 6, you get 60 degrees. That's it. That's the value of Y. The other method is, after you found the value of X, this here is also X, isn't it? Because it's a regular hexagon. Then you take 180 degrees minus your answer in part A. You will also get 60 degrees. So based on this, I can tell you straight away that X is now 120 degrees. Okay, that is an alternative way to calculate interior angle. By finding exterior angle, then 180 degrees minus the exterior angle. That's an alternative way, only for regular polygons. So with that, if this is the value of Y is found, it has the same exterior angle over here. 60, 60, then I'm sure you can do the last angle. Okay? So question 12 is also your homework question. Question 13, also homework, but I'll give you a hint. Moving on to question 13. Interior angle of a regular. So these are keywords, you must identify them. Interior angle is X. Exterior angle is X minus 36 over 3. This is a regular polygon. They give you interior angle, they give you exterior angle. What is the relationship between interior and exterior angle? What is the relationship between interior and exterior? Just now we did mental sums, right? So how do you find the exterior angle given the interior angle? 180 minus 1, get the other. You add both of the angles up, you get 180 degrees. So that is the hint for you. We are going to add. We're going to add these two and equate them to be 180 degrees. That is the relationship. To solve for part 1, we have to start off this way. X plus X minus 36 divided by 3 equals to 180 degrees. So here is a test of your algebra. You are supposed to solve this and get x equals to something. Alright? You have a x plus fraction. So you need to make the denominators the same. Okay, from here on, that's the end of the hint. Then you continue by yourself. Part B. This is for you to think about it and to scratch your head. Tomorrow we will discuss this. Okay? Kind of like an IQ question, kind of. You see what you can discover from this question. Okay? But don't stress over it. We'll go through it tomorrow. Okay. The next part of this notes. Lines of symmetry. I'm sure you have done lines of symmetry in primary school. Yes? Simple, right? Mirror image. That's all. That's all that there is to it. You know what? In secondary school, it is the same. A line of symmetry is an imaginary line, divides an object into two equal halves, and one is the reflection of the other. For example, the letter L over here, it has no line of symmetry. The letter C, letter D, and these shapes over here, they have one line of symmetry. We have shapes that have more than one line of symmetry. So now, 13a. Draw and state the number of lines of symmetry, if any. Okay? So when you're drawing lines of symmetry, please use a ruler and a pencil. I can see that there is one line of symmetry over here. So use dotted line. Besides this vertical line, is there any other line of symmetry for this figure? Any more? No more, that's all. This is just one. What about the part B? Can you please try? These are the four lines of symmetry. 1, 2, and the diagonal. 3 and 4. Okay, part C. Part C only has one. Part D, only one. Part E, only one. Now part D. Part D, can you please write down at the top, this is a parallelogram. So parallelogram, how many lines of symmetry are there? Okay, so let's have a show of hands up. Who thinks that there are 4 lines of symmetry for the parallelogram? 4. Okay, how about 2? 2 lines of symmetry. How about 0? Okay, for a parallelogram, we don't have any. It is 0. Okay, it is more obvious if I draw the parallelogram like this. Okay, from this parallelogram, if naturally some of you may think that the diagonal is a line of symmetry, but you try folding it, you're not going to get a mirror image. It is going to be sticking out this way. Okay, so a parallelogram has no lines of symmetry. However, if it is a rhombus, which this diagram over here kind of looks like a rhombus, so you may have been misled. For a rhombus, we will have 2 lines of symmetry for a rhombus. Okay? So we have been dealing with regular polygons over the past few days. So now we are going to look at the number of lines of symmetry for regular polygons. For the regular polygons. Okay, please include these words at the top. Let's try part A. How many lines of symmetry do you see? Can you find? One. Two. Right? Three. Four. And five. The 5 lines of symmetry. For pentagon, we've got 5. What about for hexagon? 6-sided figure. One, two, three. Are there more? Do you have more? 4, 5, and 6. Do you see a pattern? Can you tell me what is the answer for C without drawing? Not 7. Count properly. What is this shape? What is the name of part C? Octagon. Like an octopus, 8 legs. 8 lines of symmetry. For part D, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 lines of symmetry. Decagon. Here we've got a square, because I asked you to include these words on top. They are regular polygons, so this has to be a square. 4 lines of symmetry. For this equilateral triangle, there will be 3. You can go ahead and draw the lines, but I think it is pretty obvious about the relationship. So these are regular polygons. The sides are equal. N-sided polygons will have n lines of symmetry. Okay. Now next part, question 15. Which of the following letters in the word is symmetrical? M. Any more? A. P. H. Is S symmetrical? No, no matter how you place the mirror, you will never be able to get a reflection. Okay, so draw the line of symmetry. M, A, T, H. And last one for on this page, 16. Which of the following are symmetrical? Draw the line of symmetry. Part A, yes or no? Yes. Draw horizontal line. Part B, symmetrical? No. C? Symmetrical? Yes. Vertical line. Okay, part D, symmetrical? Yes or no? Who says no, not symmetrical? Who says symmetrical? Okay, so it is not, we are not restricted to just vertical and horizontal lines. We can have a diagonal line too. Simple. Next up, we have rotational symmetry. Okay, I'm going to bore you with the words first. Rotational symmetry is the number of times a figure matches its original in one complete cycle. Can you understand? Who can understand? Very difficult, huh? So I will show you on the board. Now, part C. For any figure, the minimum rotational symmetry The order of rotational symmetry will be 1. No matter what, there is at least 1. Okay, we don't have the luxury of a whiteboard and blue tack during our exams. So for this, letter N over here, what is the order of rotational symmetry? How will you do it? How do you know it is 2? You have to do some rotation, right? Take your paper, hold it, turn. You're staring at the letter N. You turn. Oh, my paper is upside down now. What letter do you see? You see the same N, isn't it? It is the same N. Okay, I know that is 1 count already. Continue rotating. I see a letter Z now. Continue rotating. 360 degrees rotated. I see the letter N 2 times. So the order is 2. Now the letter I over here. Again, rotate it. See for yourself. It is also 2. So now to complete this table, these are all regular polygons. Okay? Equilateral triangle, square, so on and so forth. Number of lines of symmetry, we learned that we just have to follow 5, 6, 7, 8, 9, and 10. Now, order of rotational symmetry, is it going to be the same value? Yeah, it's going to be the same. 3, 5, 6, 7, 8, 9, and 10. But there is a second part to it for your rotational symmetry. Asking you for the angle of each rotation. How many degrees do you rotate before you get the same shape, the same orientation? So for equilateral triangle, I know that it appears 3 times. I know that one full cycle is 360 degrees. So what do you think is the angle of each rotation? 360 over 3. You get 120 degrees. So every 120 degrees, you get the same equilateral triangle. So quite clearly over here, 360 degrees divided by 4. We see the square every 90 degrees. 360 divided by 5, we get 72 degrees. Okay, I'm just giving you the answers over here because I'm not testing you on the calculation over here. As long as you know how to obtain the values. For 7, it is 51 and 3 over 7 degrees. Okay, and the last page. A regular polygon of n sides has n lines of symmetry. The order of rotational symmetry is n. The angle of each rotation is 360 divided by n, which happens to be each exterior angle also. Which happens to be each exterior angle of a regular polygon. Only for regular polygon.